Hey, fabulous students. So I would like to take a look at uh, applications for three variable systems. So this is assignment 80. Um, and I want to start by, uh, do you remember back in the polynomials unit where I gave you some information about a parabola and you then wrote the equation of that parabola? 2, 5. Yeah? And so you said, okay, I know the vertex, so I'll use vertex form. And don't forget that squaring, which many students do. Plug in the vertex, y equals a x minus 1 squared plus a negative 3, so minus 3. And then to find this a value, we plug this in. 5 equals a. 2 minus 1 squared minus 3. And so that's 8 equals a, right? Because 2 minus 1 is 1. 1 squared is 1. 1 times a. Add 3. I get 8. And so my equation then can be this. And that worked really great. And that wasn't so long. And that was pretty nice and reasonable. And now we come to this problem. I would like you to write the equation of the parabola that passes through these points. I know one x-intercept. I don't see a y-intercept. I have no idea if any of these are the vertex. Um, so I can't use intercept form because I only have one x-intercept. I can't use vertex form because I don't know that any of these are the vertex. So what do I do? Well, what you get to do is use y equals ax squared plus cx, plus bx plus c. You're going to use this to help you write the equation. How? Well, I'm going to start by plugging in an ordered pair for x and y. 10 equals x is 3. 3 squared is 9a. 3b plus c. I'm going to do that for each of these points. I'm going to plug in a 2 for x and a 3 for y. 2 squared is 4a plus 2b plus c. And finally, I'm going to use this ordered pair. 0 equals a plus b plus c. And look what I have. Isn't that nifty? A three-variable system. Now, in this case, some students like to eliminate the a's, others the b's. Me, oh my god, it's so easy to eliminate the c's. But because so many students are scared that this is going to be parametric, they don't want to eliminate c's. Well, I'm going to tell you that if it's a parabola, it exists. And since it's going to be one parabola you're going to be finding, then in that situation, I definitely want to eliminate these c's. Okay, so eliminate c would be my recommendation. Take these two and eliminate c, which means all I have to do is subtract this equation from that one. And that's going to give me 7 equals this minus this, 5a, this minus this, 1b, and c minus c cancels. Okay? Now I'm going to use these two equations, again, to eliminate c. This minus this minus this, and this minus this, 1b. Now the cool thing is, look, they're both 1b. Oh my goodness, I just have to subtract. So 7 minus 3 is 4. 5a minus 3a is 2a. So a equals 2. Now that I know what a is, I can plug this a value back in to one of these two equations to find b. Now I remember that 3 equals 3a plus 1b. So negative 3 equals b. And then finally, I'm going to take this a value and this b value and plug these back into one of these three equations. I like this one down here because it's got no coefficients to worry about and equals 0. So I'm going to plug in 2 plus -3 plus c, and that should equal 0. And so I end up with c equals 1. Now, this time we're not writing an ordered triple. We are instead writing the equation of the parabola. Remember, our general form is right here. And we need to plug in our a value, we need to plug in our b value, we need to plug in our c value. So my answer to this question is going to be, well, the parabola is 2x squared minus 3x plus 1. There's our a, our b, and our c. Ta-da! So guess what? That's right, it's your turn. Remember, you want to use this general form. You want to plug each ordered pair in to generate a separate equation for each ordered pair. It's solving that three-variable system that allows you to find out what a, b, and c are, and therefore to write the equation of the parabola. Ta-da! So, yours looks like this. Will you please write the equation of the parabola through these points? 0, 3, 1, 4, 2, 3. Okay? Oh, and don't forget to use y equals ax squared plus bx plus c. Yeah, let's go. So, curiously though, this is kind of an easy problem because look, I've given you the y-intercept. That's c. I already know c. Let's imagine I didn't know that, and so I plugged a 0 in for x and a 3 in for y. So I would have 3 equals a times 0 plus b times 0 plus c. Oh look, c equals 3. That's happy. Now let's plug in 1 4. So I'm going to have 4 equals a plus b plus c, because I plugged a 1 in for those x's. And let's plug in 2 3. So I'm going to have a 3 here, and 2's go in here. So 3 equals 4a plus 2b plus c. Now, I could do what I did with my three variable systems, but you know, I already know this. I should just plug this in. 4 equals a plus b plus 3. Well, if I subtract 3 from both sides, I could now write 1 equals a plus b. And here, when I replace c with 3, and I subtract 3 from both sides, I get 0 equals 4a plus 2b. So there's my little two-variable system to solve. I'm going to multiply this top row by 2. So 2, 2, 2, and subtract. 2 minus 0 is 2. 2b minus 2b, 0. 2a minus 4a is negative 2a. So I get a equals negative 1. Not positive 1, negative 1. Now that I know what a is, I can take this a and plug this a back in, say, over here, and solve for b. So we've got 3 equals 4 times negative 1 plus 2b plus 3. Subtract 3 from both sides, I get 0. Add 4 to both sides. 4 equals 2b, so b equals 2. Okay, now I know b, now I know a, and we already knew c. So y equals negative x squared plus 2x plus 3 is my equation. And that was kind of nice that I was given a y-intercept. A y-intercept always makes these problems a lot faster. So let me give you one that doesn't have a y-intercept, and you can try that out. Ordered pairs are 1, 3, 2, 2, and 3, negative 3. Okay, don't forget to use y equals ax squared plus bx plus c and solve that. Uh, solve for a, b, and c by using three equations with three unknowns. Pause the video, come back when you're done. Hey, welcome back. Did you write 3 equals a plus b plus c when you plugged in a 1 for the x's and a 3 for the y? Don't forget to plug in the x and the y, 2 for a plus 2b plus c, and finally I'm plugging in a 3 and a negative 3. Negative 3 equals 9a plus 3b plus c. Again, you could get rid of a, you could get rid of b, but this is going to be so much faster if you just use these two to get rid of c and use these two to get rid of c. Because not only will that be easy to get rid of c in each of those cases, it's going to leave you with 1b in each of those other equations. And that'll make the next phase go much faster. So if I take these two and subtract the second equation from the first, I'm going to have 1 equals this minus this minus this, and this minus this cancels. So again, I'm going to take this equation and subtract this one. 2 minus a minus 3, 4 minus 9, and 2 minus 3. And so now I have this. And look, see, 1b's. So if I subtract, 1 minus 5 is negative 4. Negative 3 minus a minus 5 is negative 3 plus 5, which is 2a. And then finally, minus b minus a minus b, those cancel. Divide by 2, and I get that a is negative 2. Now that I know what a is, I can take this a value and plug it in here, or plug it in here, to solve for b. We know that 1 equals negative 3 times negative 2 minus b. We know that 1 equals 6 minus b. So negative b equals negative 5, which means b equals 5. Okay, and then I still need to find c. So I'm going to plug my a and my b into one of these equations. I think this is the easiest to use, so that's the one I'm going to choose, but you could choose another. And so I end up with 3 equals 3 plus c, where c equals 0. So the equation of my parabola, when I plug in a negative 2, a 5, and a 0, is going to be y equals negative 2x squared plus 5x. Ta-da! There we go. Okay, so that's nice. You need to be able to write the equation of a parabola. You now know how to write the equation of the parabola given the x-intercepts and a third point, given the vertex and a second point, and now you can find the equation of a parabola using any 3 points on that parabola, which is pretty cool and amazing. Well, I'd kind of like to do an extension of that now. I'd like you to go back to something that we talked about in the polynomials unit during word problems. We talked about Newton's position equation. A t squared plus v sub o t plus s sub o. Some of you may remember using this. This is acceleration due to gravity, and if we're on Earth, you're probably going to get a equals negative 32. Oop, that's why that's there. And this is original velocity, and this is original position. And we need to find all three of those, just like we needed to find A, B, and C in the regular parabolas. I mean, this is still a parabola. It's just got some, specific definitions in mind. In this situation, what we're going to be given is a little table of information. We're going to be told at t equals 1 second what our height is, 452. And at 2 seconds, our height is 372. And at 3 seconds, our height is 260. Yeah, I copied those down. Good. So, using these t values and these s values, I'm going to build 3 equations with 3 unknowns. I'm going to plug this in for s, I'm going to plug this in for t. And I'm going to have 452 equals 1 half a. 1 squared is 1. And when I plug a 1 in here, I have v sub o. And there's no place to plug a 1, so I just have s sub o. Nice. Now, 372, and I have 1 half a times 2 squared, or 4. So 4 times 1 half turns that into 2a. If I plug that 2 in here, I have 2v sub o, and I still have my s sub o. Finally, I'm going to plug 3 in for t and 260 in for s, and I'm going to have 3 squared is 9 halves a plus 3 v sub o plus s sub o. Okay? I have to build the three equations by using that general parabola model that Newton came up with. Now I can solve this three-variable system. So, just like we saw before, I'm getting rid of this. And that's going to be happy for me. So, I'm just going to take this equation and subtract that equation. So that's going to give me, I believe, 80 equals negative 3 halves a minus v sub o. 1 half minus 4 halves is negative 3 halves. 1 minus 2 is negative 1. And I do want to check to make sure that 452 minus 372 is in fact 80. Good. Okay. Next, I'm going to take these two, the middle one and the bottom one, and subtract those equations because this minus this, the s sub o's cancel. 2 minus 3 is negative v sub o. 2 minus 9 halves. Well, how many halves is this? I have to multiply top and bottom by 2. 4 halves minus 9 halves is negative 5 halves a. And on the other side, what's 372 minus 260? Is 112. So now I see this opportunity. I mean, I could certainly multiply everywhere by 2 if I wanted to. But why? Because minus v sub o minus a minus v sub o, those cancel. And minus 3 halves minus a minus 5 halves. Minus 3 halves minus a minus 5 halves. That's minus 3 halves plus 5 halves, which is 2 halves, or 1. Well, that's nifty the way that worked out. These eliminate, I get 1a. And over here, I have negative 32. And that's what I should get if I'm talking about imperial units of measure, and I'm talking about doing this on planet Earth. They should always be negative 32 if we're talking about feet. If we're talking about meters, that'd be 9.8. But since we're talking about feet, this is always going to be negative 32. That's a nice check on these problems. So now that I found a, I can plug a back into one of these equations to find v sub o. I'm going to use this top equation. So 80 equals negative 3 halves times negative 32 minus v sub o. Well, I can do some canceling here. Negative times negative is positive. 16 times 3 is 48. And if I subtract 48 from both sides, I end up with negative v sub o equals 32, and v sub o is negative 32. Now, this negative 32 is not the same as this negative 32. This is acceleration due to gravity, and this just happens to be how fast we're moving. We're moving down at 32 feet per second. Okay, but now I know a and v sub o. I can plug those into one of these equations to help me find s sub o. I like this middle equation because it doesn't have these fractiony bits. Yeah, it's no problem because they're just 2's, so we could do the fractiony bits. But I'm going to go with that. 372 equals 2 times negative 32 plus 2 times negative 32 plus s sub o. So 372 equals negative 64 minus 64 is minus 128 plus s sub o. I'm going to add 128 to both sides. And I end up with 500 equals s sub o. So what's my equation? Remember, I'm not done until I build the specific motion equation for this. I have to fill in these values. I've got S of t equals 1/2 negative 32t squared minus 32t plus 500. And yes, I would tidy that up to be negative 16t squared minus 32t plus 500. Okay? So, same as building the equation for a parabola, but I'm looking not for a, b, and c, but a, v sub o, and s sub o. Okay? So here's yours. We know that at time equal to 1, you're at 132 feet. And at time equal to 2, you're at 100 feet. And time equal to 3, you're at 36 feet. Time and position. Don't forget you're using S equals 1/2 AT squared plus V sub O T plus S sub O. Pause the video, give that a go. You really need to be able to do that on a test. That would be fabulous if you could do that on a test. Please do that on a test. And after this, we'll look at a couple of word problems, and then we'll be done. All right, so the first thing we have to do is build our system of equations by plugging in these values for t and these values for s. 132 equals 1/2 a plus v sub o plus s sub o. 100 equals, I'm plugging a 2 in here. 2 squared is 4. 4 times 1/2 is 2a plus, I'm plugging in a 2 here, 2v sub o plus s sub o. And finally, I'm plugging in a 3 for t and a 36 for s. When I plug in a 3 here, 3 squared is 9. 9 times ½ is 9/2 a plus 3v sub o plus s sub o. Okay, so I've built the system. Now I'm going to take these two and eliminate s sub o. This minus this minus this. Okay, so that's 1/2 minus 4/2 is negative 3/2. This minus this is minus v sub o. This minus this, they go away. Then I'm going to take these two, this minus this, 64, this minus this. Well, this is 4/2 a minus 9/2 a is negative 5/2 a. And this minus this is negative v sub o. Well, that's really nice, because now I see these are the same. I want to subtract. 32 minus 64 is negative 32. Minus 3/2 minus a minus 5/2 is going to be positive 2/2 a, or a. And then minus v sub o plus v sub o, those cancel. Yay, I got the a I was expecting. Now I'm going to take this a value and plug it back into one of these two equations to help me find v sub o. 64 equals negative 5/2 times negative 32 minus v sub o. And so I get 64 equals 80 minus v sub o. If I subtract 80, I get negative 16 equals negative v sub o. So v sub o equals 16. Okay, I've got v sub o, I've got a. I still need to find s sub o. So I'm going to take these values and I'm going to plug them in up here. Again, I can plug them into these, but I'm going to choose to do that one. So what will it look like when I do that? 100 equals 2 times negative 32 plus 2 times 16 plus s sub o. And so I'm going to have 100 equals negative 64 plus 32 plus s sub o, or 100 equals negative 32 plus s sub o. And if I add 32 to both sides, 132 equals s sub o. Great, so that is my initial height. Therefore, my equation for this parabola will be s equals 1/2 negative 32 t squared plus 16t plus 132. Yes, I'm going to tidy that up. S equals negative 16t squared plus 16t plus 132. And no, don't expect these always to be the same or opposites. That's just a fluke that's happening here. All right. Well, I encourage you to practice some more of those if that's still difficult, or come ask me some questions. We're going to take a look now at um, one or two word problems. And, at this point, really, you should start getting comfortable for this word problem stuff because they're so familiar in pattern. Um, yeah, I think much of the trauma you have about word problems has to do with all those years when there wasn't a recipe or you didn't understand how to do them. Now you really should be getting to that place. And if you're not at that place where word problems still scare the hell out of you, you really need to be asking more questions and not just saying, oh, I got this, or I'm not going to worry about that. Because, the ostrich does that, and you are not an ostrich. Okay, do you remember from a couple videos ago how interest was equal to principal times rate times time? And that how in all these problems time was always going to be 1 year? Well, guess what? Now, a small corporation borrows $775,000. And some of that money was borrowed at 8%, and some of that money was borrowed at 9%, and some of it was borrowed at 10%. And you might be saying, well, why didn't they just borrow all of it at 8%? And that's because once they had borrowed a certain amount of money at that rate, the bank said, well, if you need to borrow more money from us, you're going to have to pay 9% on that. And in fact, after they borrowed money at 9% to a certain amount, then the bank said, yeah, no, you're too risky for us unless we charge you 10%. And so that's why this is happening. Okay, we know that the annual interest owed on borrowing all this money was 67,500. That's our interest. Okay? And finally, we're told the amount borrowed at 8% was 4 times the amount borrowed at 10%. So let's say that A is the amount borrowed at 8%, and B is the amount borrowed at 9%, and C is the amount borrowed at 10%. And what they're telling me here is the amount borrowed at 8%, A, is 4 times the amount borrowed at 10%. And so that's actually my third equation. That last sentence in the problem, so the sentence says, um, how much was borrowed at each rate if the annual interest owed was 67,500? The amount borrowed at 8% is 4 times the amount borrowed at 10%. Okay? So that's great to have that equation, but what about the first two? Well, we talked a couple videos ago about one of them being a quantity equation, A plus B plus C equals all that money that you're borrowing. And then I had a value equation where we said, okay, that interest is going to be 8% times that amount of money plus 9% times that amount of money plus 10% times that amount. And so now I got my 3 variables and 3 unknowns. And I think rather than solve 3 variable system here, I think I'm just going to do substitution. I think I'm going to replace my A's with 4C's. So this becomes a 4C, and then 4C plus 1C, I'm going to have 5C. Oops. B plus 5C. Okay, and here I'm going to replace this A with 4C. So 0.08 times 4, well, that's going to be 0.32C. So we now have 0.32C plus another 0.10C, so that's going to be 0.42C. 0.42C. There we go. Okay, so here are my two equations. Again, if you want to do substitution, that's fine. If you want to use elimination, that's fine. I'm never going to care how you solve this. I think I'm going to multiply this row by 0.09. So 0.09 times 5 is going to be plus 0.45C, and 0.09 times $775,000 is going to be 69750. Oh, okay. 0.09B plus 0.42C equals 675. So I've got these two equations now. And if I subtract, I get 0.03C equals, that's 2,250, I think. 69750 minus 67500. Yes, 2250. But I don't want to know what 0.03C is. I want to know what C is. So I have to divide both sides by 0.03. And when I do, I see that C equals $75,000. But I still need to find how much was invested in A and how much was borrowed at 8 and how much was borrowed at 9. So if I take the C value and plug it in here, I can know that A is going to be 4 times this number, or 300,000. And I'm going to take these and plug them into one of the original equations, or just say, well, I borrowed $775,000. Here's $375,000, and so B must be $400,000. So I borrowed $300,000 at 8%, $400,000 at 9%, and $75,000 at 10%. Okie doke. All right, so let's see you do one of these problems now. I would like very much to see that. And here is yours. So this one says, that you are actually putting investments. You're putting $500,000. I know, it's pretty something, huh? Into 4 investments. And it says here, I'll read it to you. Consider an investor with a portfolio totaling $500,000 that is invested in certificates of deposit, CDs, mutual bonds, blue chip stocks, and growth stocks. Okay, I don't want to use all those letters, so I'm going to do these letters. Okay, certificates of deposit. M was municipal bonds, B was blue chip stocks, and G was growth stocks. Okay, and what it then goes on to say is how much is invested in each type of assessment. We're told in our question that certificates of deposit pay 10%, which is truly amazing, and you can't find that on this planet these days. The municipal bonds pay 8%. Blue chip stocks generally return 12%, and growth stocks 13%. Finally, it says the investor wants a combined annual return of 10%, which means they want to be making 10% of this number, or $50,000 in interest every year. We're also told that they want to have only 1/4 of this total portfolio in stocks, blue chip stocks or growth stocks. So we also know that blue chip plus growth equals 1/4 of this portfolio. Is that what it said? Investor wants annual return, also want 1/4 in stocks. So 1/4 of 500,000 is 125,000. Okay, so here's one of my equations. What about my value equation? I know 500,000 equals C plus M plus B plus G. And my value equation that comes with that interest 50,000 in interest equals 0.10C plus 0.08M plus 0.12B plus 0.13G. Okay, do I have enough information? Well, I don't feel like I do. Um, because I've got 1, 2, 3, 4 variables, and I only see 1, 2, 3 equations. And that's going to be parametric. Unless I have the same number of equations as I have variables, this is going to be parametric, but we're assured here that there's an answer. So let's go back and read this stuff some more and see if we missed anything. Consider an investor with a portfolio totaling $500,000 invested in certificates, bonds, blue chip stocks, growth stocks. How many are invested in each type? And so then our problem says certificates of deposit pay 10%, municipal bonds pay 8%. Over a 5-year period, the investor expects blue chip stocks to pay 12% and growth stocks to pay 13%. Okay. The investor wants a combined annual return of 10% and also wants to have 1/4 of the portfolio in stocks. Yeah, well, no, I think we got it all. So, I think what's going to happen is that, yeah, I think it'll all work out in the end. I got my fingers crossed. So, B plus G is 125,000. Well, I see a B plus G here, so I'm going to turn that into 125,000. And then subtract 125,000 from both sides. And so I know that C plus M equals $375,000. And that makes sense to me because if I put in 1/4 of the money into stocks, then 3/4 of this money should be in the CDs and the municipal bonds. All right. Now what? Well, yeah. Yeah. I kind of want to get this so that it's only there. These aren't the same. Well, let's try some substitution. B equals 125,000 minus G. And if I plug that in here for B, I'm going to have 50,000. No, it's still not going to work. Huh. What am I missing here? That's very interesting. I have a written up solution, but I don't like my written up solution. I don't like my written up solution because it doesn't make sense. Here, you help me. This is what I've got. I got 500,000 equals C plus M plus B plus G. Okay, so we have that equation. And then I've got 0.1 times 500,000. Remember, they wanted a return of 10%. I've got 50,000 equals 0.13 times 12,500 plus 0.12b plus 0.08m plus 0.10c. Now that number, where'd that number come from? Oh, sorry, 125,000. Well, I've got down here where it says stocks. Well, stocks are blue chip plus growth. And blue chip plus growth, they said 1/4 of the total, 500,000. and we determined that that would be 125,000. But that's b plus g. But in my notes, I don't have b plus g. Huh. They are stocks, aren't they? I'm going back to read the problem a fourth time now. Okay, says here, blue chip stocks and growth stocks. Yes, these are both stocks. Yeah, you're not going to see anything like this on a test from me, so don't worry about that. But let's have our intellectual curiosity, and let's say that there are these things called stocks. We know stocks are B plus G. So I guess I could do some rewriting here. No, because that's, yeah, no, 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 I'm completely bailing because that doesn't make sense to me. And so I'm going to need to go sit down and have a nap and maybe a piece of chocolate cake and, that's sort of thinking about this stuff for a little while before I come back and try it again. So maybe I'll bring it up for assignment 82, which is our very last instructional video for the semester on new content. But maybe I'll just be really excited about that. All right, if you have questions on these, please don't hesitate to let me know. I will talk to you soon.